To be clear, notice the word up here, flip side view in bold. That's why that appears there, simply because they defined it like that. All right, so let's see what's going on here. So show info is probably the most interesting thing. Show info is what happens when I click this button. That method is called. So let's take a look. Flip side view controller. It's all kind of wrapping onto two lines here. But what happens when you click the I? Apparently, you're allocating a flip side view controller with alloc. You're initializing it with the nib name called flipsideviewcontroller.xib. The .xib is implied, and bundle is nil. We can wave our hands at bundles for now. And then you're assigning the address of that newly allocated object to a pointer called controller that's of type flipsideviewcontroller. So in short, you're allocating a new view controller because you want to hand off control of this application. Notice next, you're telling that newly instantiated controller that the delegate is yourself. And to be clear, why do I execute this second line of code? What's the point? Why am I informing flipside view controller of myself? So think of it. What's that?
It's a whole different view. So
it's a whole different view.
it needs to know how to get back.
Correct. It needs to know how to get back. So think about this in C style. If foo calls bar, bar has no idea who called him. Right? In the world of C, if a function called foo calls a function called bar, bar knows it got called, but it has no idea to whom. Now, underneath the hood, if you've taken 61, you know that there's actually, on the stack, there's a return address, but that's all hidden details from the bar function. So in this model, though, if I click the I button, I better inform the guy I'm calling who I am so that he can return control back to me. Otherwise, you're going to hit the I button and the UI is going to change and it's going to be stuck there forever because it has no idea who you are unless you hard code it in that class, but that would just be bad design. Right? This delegate model is a very, very common paradigm in iOS where you inform some other object of who you are so that it can pass messages back to you in the future. So this is just giving that pointer to the flip side. Now, what's this doing? This is where the sexiness comes from. So controller.modal transition style is UI modal transition style flip horizontal. So ridiculously named, but this is an enum'd constant that's declared in the SDK. So it's just a number, but we don't know what the number is because it's kind of abstracted away. This is what makes that very sexy iOS transition for me. You don't have to do any of the math yourself. Then lastly, self present modal view controller. Controller animated yes. So what does this mean? A modal in UI design means what? What's a modal window? This exists in the world of HTML and CSS too. Yeah?
Transparent background.
So often, transparent background, but that's not what characterizes it per se. A modal window is one that, yep, Zach? It's often a pop-up, but that too is sort of incidental. It's a window that requires your interaction to the exclusion of anything else that appears to be behind it. So there's the transparency, there's the pop-ups, but these are all just aesthetic incarnations of it. A modal means you are forced to interact now with that window. You can't still access as by dragging things around the thing behind it. So this makes sense. When this thing flips around, obviously you can only interact with one side of it, so it's modal in that sense. Now, present modal view controller, we can see that this could get very less interesting quickly. If I change animated from yes to no, go ahead and recompile this thing, a lot of the things we take for granted in iOS start to disappear. And yes, this works, but man, isn't it sexier when it flips around like that on your phone? All right, so in short, the show info method is what's called when we click that button. So what does that mean in terms of the nib? Well, let me look at mainViewController.nib and then control click or right click on the I, and notice that sure enough, touch up inside is mapped to the method called show info. Well, now all that remains of this story, even though this app doesn't do all that much yet, is what's going on inside of the flip side view controller. Well, here's the flip side. I've clicked on flip side view controller nib. Notice that if I expand all of these objects, notice that I see a hierarchical list of everything that someone at Apple dragged and dropped onto this user interface. And I can start tearing this apart. If I really don't like the done button, I can just go ahead and get rid of that altogether, or I can change the wording of it by actually changing the type of it with a constant in code or in interface builder. But in short, this is something that someone has dragged and dropped and prepared. So what happens if I click the done button? Well, I'm curious. Suppose my partner and not someone at Apple did this. Well, apparently, when the done button is clicked, it's going to call the file's owner's done method. So that's some other method that we looked at. So let's go look at that real fast. So files owner's done method is apparently in here. This is in the flip side view controller. I click the done button. The behavior I want to induce is flipping it back to the main view. So what happens when done is called? I call self.delegate. What is self.delegate a pointer to? The main view controller, because I, the main view controller, assigned that property before I handed off control to this modal flip side controller. So I'm passing a message to the main view controller. Flip side view controller did finish. So it's intentional that Apple called this method in this way. Think back to the UI, what was it? UI alert view did dismiss with button index. So this verb did is very common in this event handling paradigm where you want to signal that something is done executing. So flip side view controller did finish self. Now what's going on there? What is flip side view controller did finish? Well, notice in the header file that is apparently a method that a class must implement if it has promised to implement the flip side view controller delegate, which was the new word that Yella pointed out earlier was in the main view controller's header file. Recall that in the main view header file, we implemented not just a UI view controller, we also promised to implement this thing. What does this mean? Well, I had better implement, I being the main view control, a method called flipside view controller did finish. That is the method that's called to inform me, the main side, that the flip side is done executing. So if I go into my M file, there it is, and it's super simple. When that method is called, I simply pass to myself the message dismiss modal view controller animated yes. And that simply flips it back around so that you see the main view again. So this is what's key about modals. You can think of the main view controller as literally being the main guy. He is in charge of everything. And if you want to see something else, he will temporarily present a modal, but control will ultimately be passed back to him. How? The flip side will say, I'm done. Go ahead and tear me down. And the means by which you tear down the modal is by passing to yourself this dismissal message, dismiss modal view controller. And the animated is just fluffy aesthetics. So again, the key takeaways today are not so much how to actually write these fairly trivial applications, trivial in that they don't do all that much, even though there is a lot of code and wiring going on, but these common paradigms where one object is talking to another, where one object is informing another to whom it should send messages back some number of seconds or minutes later, so that we have fairly loosely coupled systems here, so that main view controller hands off control to flipside, and flipside only knows about its existence by way of that delegate pointer that we installed. And you'll see that just as this utility application adheres to this model, so do a lot of the classes throughout iOS. So in Evil Hangman, you'll have to start thinking about a few things. So one, you start with the utility application. So right out of the box, your thing's going to do this, which is great because it feels like you're making progress. You can burn that onto your phone, show your friends, and you just have to finish implementing the game after that. So on the game side, you're going to have to implement some kind of UI, and it can be purely text-based. It doesn't need to be drawings and whatnot. You can just use UI labels and similar, and the spec makes a lot of recommendations, but you're somehow going to have to model this gameplay. So we propose in the spec that you must implement a gameplay delegate protocol in two ways. You have to implement a good gameplay, which is sort of the old school, traditional, non-evil way, and then you have to implement another class called evil gameplay that has the same methods for gameplay, and we leave it to you to define what those methods are, but that's going to play in the evil way, where it's going to not really pick a word in advance, it's going to try to dodge guesses from time to time, and that's the one that's going to be fun to play against your roommates. So with that said, that's Evil Hangman. That's it for iOS today. We'll see you on Monday or at office hours this Tuesday, Wednesday, and Thursday, in addition to the walkthrough on Wednesday. See you then.